1.3c is on inequalities in the real world. So we're going to look at some real world situations and create and solve some inequalities here. So take a second and think about synonyms, right? So if you're thinking about less than or equal to, greater than or equal to, what are some synonyms for those signs? What's another way you could say that your grade has to be greater than or equal to an 80% to get a B, right? What's another way you could phrase that? So here are some examples, right? So for example, if we wanted to say more than, that's the same as saying greater than. Or if we say that you have to have at least that many credits to graduate, then you can have greater than or equal to that number. Okay? So looking at this vocabulary, pause the video, take a second to familiarize yourself with it. As you're looking at word problems and different phrases, these are just different ways, different things that you say that talk about or mean less than, greater than, less than or equal to, greater than or equal to. So let's look at a couple real life examples, and then make sure that you reference this list if you're unsure about, like for example, if we say at most, right? Reference this list to determine that you would use the less than or equal to sign. So we want to write the inequality for each statement. So letter A, the food will cost less than $7. Well, we're trying to figure out how much the food will cost, right? That's our X value. That's what we're talking about here. Well, it says less than. So X, or cost of food, will be less than $7. Since it specifically says less than, it can't be equal to because it tells us it's just less than. Letter B, you need to get at least an 82% on the test to get a B. So let's think about what that means. You could get an 82%, you could get an 83%, you could get an 84%. You couldn't get an 81% because that is not at least an 82. So your grade, X, needs to be greater than or equal to 82%. Okay? And actually, your grade needs to be less than 90%, right? Because if it's up to 90, then it's not a B anymore. It would be an A. Last but not least, letter C. It'd be a good idea to pause it and see if you can figure this one out. You can have at most 2 cookies. So let's think about this. If you can have at most 2 cookies, how many cookies could you have? You could have 2, you could have 1 cookie, or you could have 0 cookies, right? At most 2 cookies. So since 2 is the most, you couldn't have 3, and then you can't really have a negative number of cookies. So these are the values we're looking at. So we're actually going to have a compound and inequality like we did in B. So our lower bound is 0. 0 is the lowest number of cookies you could have. Right? So that's less than or equal to your number of cookies, X, which is less than or equal to 2, the greatest number of cookies you could have. And that's our inequality. Let's look at some word problems, okay? So Katie has $20 and wants to buy bracelets that cost $1.30, but first she had to give her little brother $3. We want to write an inequality of how many bracelets she can buy. Well, the problem says how many bracelets can she buy? That's what we're looking for, so that's what our variable is. X is the number of bracelets. Whatever your question is asking you, that's what your variable is 100% of the time. So X is the number of bracelets. That's what we don't know. That's what we need to figure out. So let's take a look at how Katie can spend her money. Well, she's got to give her brother $3. So she's got to give her brother $3. Okay? And after that, she's got money for her bracelets. But it costs $1.30 for every bracelet. So $1.30 times X, because X is our number of bracelets. Now this amount, right, if we think about it, if Katie has $20, Katie could spend $20, or she could spend anything less than $20. So our inequality is 3 plus $1.30 times X needs to be less than or equal to 20. Right? It can't be greater than because she can't spend $21 because she doesn't have $21. The store is not going to take her IOU. So it's got to be that less than or equal to. It can be equal to because she could spend exactly $20, right? She has the money to do that. So now that we have our inequality, we are going to solve it just like we have in past lessons. So we're going to isolate our x. So I'm going to subtract 3 on either side to get 1.30 times x is less than or equal to 17. Well, we're multiplying here, so we're going to divide to isolate x. So x is going to be less than or equal to 17 divided by 1.30 is 13. So the number of bracelets x needs to be less than or equal to 13. So at most, right, Katie can buy at most 13 bracelets. And notice how that at most, I'm using that vocabulary that we looked at the beginning of the lesson. Okay, so Katie can buy at most 13 bracelets. Now she knows, right? So get a couple more problems. So it would be a good idea to pause and see just how far you can get, right? See what you're understanding. You are going to an amusement park with $25. Admittance costs $5, and each ride costs $1.25. How many rides can you go on? Well, let's set up our problem very, very similar to the previous one. We have to pay $5, right? Just because we're going into the park, we have to pay $5. Okay, and we're going to pay, apologies, I skipped a step. How many rides can you go on? Since we're looking for the number of rides, that's our variable. Okay, and our rides cost $1.25, so we can find our cost of rides by taking $1.25 and multiplying it by the number of rides we go on. Now all of this has to be less than our total amount of money, right? So if we have $25, well, what we spend has to be less than $25, or we could spend exactly $25. So we have 5 plus 1.25x is less than or equal to 25. And again, from here, we just solve it. We can subtract 5 on either side. So we have $1.25x is less than or equal to 20. Since we're multiplying, we're going to divide, right? The inverse of multiplication is division. So we have x is less than or equal to 20 divided by 1.25 is 16. So x is less than or equal to 16, which means you can go on at most 16 rides. At most 16 rides. That's what it means. Okay. So we're going to look at one more problem. Again, it's a good idea to pause right now and try and define your variable, try and set up your inequality, and then check your answer. Okay, that's how you can determine if you're understanding. So you see an advertisement for instructions on how to tie flies for fishing. The cost of materials for each fly is 15 cents. You plan to sell each fly for 58 cents, and you want to make a profit of at least $200. Okay? How many flies will you need to tie and sell? Well, how many flies? That's what we're looking for. So our variable x is the number of flies that we need to tie and sell. So we actually have two parts to this. We have what we need to tie, and we have what we need to sell. Okay. So it tells us that the cost of materials for each fly is 15 cents. So that part is going to be 0.15 for each fly, so 0.15 times x. And then we sell each fly for 58 cents, so that's going to be 0.58 cents x. Well, since it costs us 15 cents, that means we're spending that money, right? So to signify that we're spending that money, we're going to subtract that. So we are going to take our 0.58x and subtract 0.15x. And we want to make at least $200. So if we think about at least, that means $200 is the smallest amount of money. So whatever we make with our 0.58x minus 15x needs to be greater than 200. So at least, it could be exactly 200, right? 200 is the lowest number, but it's got to be greater than or equal to $200. And from here, we just solve. 0.58x minus 0.15x is 0.43x. This is greater than or equal to 200. Divide by 0.43. Divide by 0.43. X needs to be greater than or equal to 466 flies. So to finish this off, you must sell 466 flies at least 466 flies, at least 466 flies to make a profit of at least $200. Okay. Something I want you to notice is how similar this is to setting up an equation for our other word problems we've looked at. Right? Obviously, you have to determine what kind of sign it's going to use, but other than that, the setup is very, very similar.